Hello, my name is Angad Kahlon, and I am in Comp 380 for the semester Fall 2023 at UFV. This is Lab 7 about relational logic. So, in the preliminary questions, we have question 1, which is describe the basic idea of a top down proof procedure. So, basically, the top down proof procedure is a strategy used to prove complex problems by breaking it down into smaller subproblems or by proving something by proving all the goals that lead to it. To start, you have a large and complex problem which you divide into smaller subproblems or have known facts in a knowledge base, and keep dividing until you reach the base cases where common sense and basic functions can be used to prove the base case. After you prove all the base cases, you work your way up to the small subproblems in the small subproblems until you've proven all the small subproblems and reach the original main goal, which can be proven easily. So in terms of AI, we have a knowledge base KB, and we can use the top-down proof procedure to check if the previous query or back in the backward direction is a logical consequence of the knowledge base, meaning if we have information in the knowledge base, then we can keep on going ahead and reach the main goal. So my sources were this for this question. Question 2, how do you know when you have completed a successful derivation using top down? So you know it's been successful when the main goal has been proven with nothing left unproven. So none of the subproblems are unproven, and it is consistent with any assumptions. Question 3, give an example of admissible heuristic for top-down search. So going back to the definition for admissible heuristic, which is a non-negative underestimate, so never overestimates the true cost or distance from the current state to the goal node. So in terms of top-down search, if we have a starting point A, which we want to reach, and we have three paths with costs 2, 3, 4 respectively that lead to the goal, an admissible heuristic could be, for example, 1 for path 1, which had a cost of 2, since it's underestimate. So using admissible heuristics help us to make the top-down search efficient and remove any subproblem paths that do not lead to the starting point or base case. So for part 2 of this lab, we had a scenario where universities are accepting students, and there is three ways to accept. So if a student is returning to the university after a time away, they have to be in good academic standing with no outstanding fees. Students who have submitted a complete application are qualified and are qualified are also accepted. And students are qualified if they have high SAT scores as well as good high school transcripts. And they also have a legacy program. So in this scenario, we have a Sam. We have three individuals: Sam, Chris, and Laura. Laura's a returning student in good academic standing. Sam is a former graduate, and Chris is his son. And Chris has good high school transcripts and has submitted a full application. So here we have all the rules and information. So rules 5 to 10 are just the base cases in the knowledge base. So question 4 is saying show a successful top-down derivation of the query accepted Chris applied to your knowledge base, starting with yes and ending with yes. So here are the steps written out in words, but I've also made a little tree here, which is a bit easier to understand. So we start off with yes, and from yes we go to accepted Chris. We look at rule 1, which is one for the two rules for accepted student. We can't apply rule 1 because Chris is not a returning student, so we have to apply rule 2. Rule 2 says that it has to be app complete and qualified. And for app complete, we can see that we've already have the information in the knowledge base. And for qualified, we're going to need to use the legacy student and high stat and good HS student information. And for the legacy student, we're going to need the child and graduate information. So if you go down here, we break down that rule 2 of accepted Chris into qualified and app complete. And it's a known fact that Chris has app completed, so this branch is true. And in rule 2, we have qualified Chris. So we can apply, we break that down to legacy student Chris, high stat Chris, and good HS Chris. So for this branch, these are known facts in the knowledge base as well. So this whole branch is proven true. And then for legacy student Chris, we have child Chris Sam and graduate Sam. I've just inputted the parent name too. And these are also known facts as Sam is a previous graduate, so we can apply graduate Sam. And Chris is Sam's child, so we can apply child Chris Sam. And this is somewhere where the heuristics come in handy because we didn't have to explore this branch. So a heuristic would have been handy here. So for part three, we were supposed to use AI space. I was facing a bit difficulties with entering the knowledge base, so I wasn't able to complete this portion. But for question five, where it says, "Can you find a successful derivation for accepted LoRa?" A successful derivation for accepted LoRa cannot be found as there is no way to prove clear balanced LoRa in the knowledge base, meaning we can't use rule 1, and there's no information about app completed LoRa or qualified LoRa, meaning we can't apply rule 2. The only information we've been given about LoRa is that she's returning and in good standing, but that is still incomplete for this rule 1, and that's incomplete information for rule 2. So thank you so much for watching.